Record to the cloud. All right, you're live. Alrighty, welcome everyone to ACM Hack's Essence of Backend Engineering workshop on SQL. Is pronounced SQL or SQL or however you want to pronounce it. But yeah, myself, Shravan, and Ryan will be teaching this workshop. This is going to be the third part in our Essence of Backend Engineering series. This workshop doesn't require any previous knowledge or previous attendance of Essence of Backend Engineering. So this is your first workshop in the series. Welcome. You won't need any of the previous knowledge for this one. So let's go ahead and get started with the workshop. So I've just posted this in the chat, but if you want a link to the slides, you can find them right here. I recommend following along with the slides, or at least having them open, because we will be covering a lot of content and syntax related to the language that is SQL. So when we start writing our own SQL queries, it might be nice to refer to those slides that we kind of cover with the syntax. So I recommend everyone to pull that up. The check-in code for this workshop is SQL Hack. You can check in with that link. Steven just posted a link in the chat. I'm actually going to check in with that as well real quick, so I don't miss my workshop. But yes, if you're not familiar with ACM's membership portal, we have a website called members.acmecs.com where you can create an account and you can check into events by entering a check-in code, and you'll earn a certain amount of points. You can view the leaderboard and see people with all the points they've gained in this year. And then also you can go to the ACM store and buy some items, like real life items with these points. So it looks like a new collection just dropped, the community collection. So you can buy some stickers, some frisbees, some t-shirts, etc. I didn't realize how wealthy I am, but I guess I could buy a lot of shirts. But yes, that's what the points are for. You can do so there. Let's get right back to the presentation. So yeah, for today's agenda, we're going to be talking mostly about databases and SQL, as well as a little bit about object relational mapping, which I'll explain at the end of the workshop. But first, let's talk briefly about some of the stuff we covered previously in the Essence of Backend Engineering series, for those of you who might not have attended those workshops. So as I mentioned before, this is the third workshop in this series. This one is on SQL, which is database related. We had two previous workshops. One that was an overview of backend engineering. So we talked about what is backend engineering, what do backend engineers do, and roughly how the internet works at a high level. So things like HTTP and like how the internet's connected with like cable, Wi-Fi, Ethernet, that kind of stuff. In our APIs workshop, which was last week, we talked about what an API is. So an API is an application programming interface that serves as a middleman that backend engineers write for front ends or for like clients like a web browser or like a website to access some kind of data that the backend is storing. So the APIs define set amount of like features that any user can interact with the data that we store, and that API defines like safe, secure, fast ways of accessing data essentially. We won't be working with APIs in this workshop, but we will be working with the data aspect of the backend in our databases section here. So essentially, the APIs are safeguarding the data that we're going to work with in this workshop. Next quarter, we're going to be having two more workshops, one on Docker, which is a really cool technology around the concept of containerization. So we'll talk about that next quarter, as well as distributed systems, which will be our advanced workshop on working with multiple services and working like how to send requests between different services and looking at that kind of stuff. So it'll be exciting. I briefly mentioned what an API is already, but last workshop we did cover like a waiter analogy where the client in our case would be like a customer. The API would be the waiter. So you would ask the waiter for something that's in the kitchen, right? And the server, like the data, I guess, would be the kitchen. Like a client wouldn't just walk up to the kitchen and grab their own food. The middleman is the API, which verifies that what they want is actually there, or throws the customer out if they're causing too much chaos, like that kind of stuff. So that's basically what an API is. Last workshop, in our API workshop, we did cover over a use case of an API, which is our auction house. This was a kind of fake example we created to see how we can build our own APIs. We won't be touching too much of the auction house this workshop. We're going to cover that in the ORM section at the end. But essentially, we kind of looked at the scenario where what if we want to implement a sort of auction house system where users can create auctions and other users can bid on those auctions. And then the highest bid at the end of the auction will actually get the item. And then users can have like logins and etc. and like salaries or like balances, like amounts of money they have. So we looked at that use case and we designed a couple of API routes to actually support this feature. So we have get auctions, get auction by ID, post auction, post an auction by ID with its bid, and post user. If you're not too familiar with the syntax, that's totally fine. We won't be working with this at all in this workshop, but that's a little bit about the API section of backend. So the question then that we kind of left open at the end of last workshop is, where does this auction data actually store, right? If we have a system that is meant to store auctions and they're meant to store bids and users, like where is that data actually being stored? Well, in our example that we went over in our previous workshop, and if you didn't look at the code, that's totally fine. This is all the code you really need for what I'm trying to say. But we essentially stored auctions, bids, and users in like a data structure in our code. So here we used a map object. This is TypeScript syntax. So we use a map that maps like string to auction. So it maps a ID to a particular auction. And essentially, that's how we store data. So if we wanted to add an auction to our database, we just insert it into the map. And then when we want to get an auction from the database, we just look it up in our map. So if you've taken CSE 12 or like a data structures course, this is equivalent to like a hash map in its storage. So that's what we kind of use for our database. So my question to you all, and if you can answer in the chat or speak up, is there any issue you see with storing data like this in an actual system? Let's say I want to deploy an auction system for the whole world to use. What would be the issue with storing data in data structures like this? Does anyone have any suggestions for answers? Anyone? Okay. So I'll kind of explain what's going on here, but essentially we're using data structures in our code to store data that we want to persist forever, right? So if we want to store data that can be accessible by other users or other users across the world or across the country, we need some way of storing that data like permanently so that other people can use it. And if our server goes down, then that data is still there and it can be used. The issue with data structures is that this data is not persistent. Whenever, like, let's say I run this program and it creates a server that has all these auctions and bids and users, the second I turn off that server, all the data is gone. So let's say I am coding something, right? I'm like developing on the code for this auction system and I need to like recompile my code. Then all the auctions and bids and users that I just tested with are all gone. And for those of you who went to last quarter's workshop or last week's workshop, we actually saw this issue a lot where a lot of the data we were working with just disappeared because it's not persisted anywhere. It's not stored on disk. It's all stored in memory, and memory is temporary. And when the program shuts off, or when let's say you execute a Java program and then the Java program finishes, all the data that's stored in those data structures is gone. So what we need is some way of storing data persistently, right? Some way we could store data on disk such that we can actually access that data all the time and it's persistent when we shut down a server or if our server goes down, etc. So this is going to be the topic of databases, and we're going to see here how we can actually store data persistently and connect our API to our database in order to communicate data across different services. So I'm going to hand it off to Ryan to talk a little bit about databases and what they are.
Yeah, so basically I'll be covering in databases and essentially what they are. So Sravan, if you can go to the next slide. Basically, a database is going to be a data structure that contains organized information, right? And so this is just like a set of information that's basically organized together and essentially related to one another, right? So for example, you have UCSD, which might contain a database that holds information regarding stuff related to UCSD, right? The different courses that UCSD offers, the different students that are at UCSD, the different faculty, dining halls, etc. And essentially with databases, you can have different types of databases, and depending on the type of database, the mechanism for storing data would be different, right? And so there's different ways of structuring databases. And basically in databases, you want to be able to manage the data that you have, right? And so with that, there's essentially a set of methods and I guess mechanisms that you can be going about doing that, right? So one of them would be to create data, right? So inserting data, creating the table, etc. You should also be able to read the data that's in the database to ensure that you're able to collect information that's actually in the database. You can update databases where you have instances in the database or data that you want to sort of modify or update. And lastly, you can also delete instances of data in the databases as well, right? And so one other thing is data should generally be stored with specific data types. So for example, you want to match the corresponding type to whatever data you're storing. An example of this would be like a student's first name, which is a set of characters, right? So it could be like John, whatever it is, and it should be associated with the type of string, right? In contrast to a student's graduation year, which is a set of numbers, and you want to essentially associate that with an integer. Cool. And so with the next few slides, I'll be going into different types of databases and the different mechanisms that sort of follow that and what the structure sort of looks like. Okay, so the first one I want to cover would be the key value database, which basically stores data in a key value pair, right? And so you can sort of think about this as sort of like a hash map or maybe like a dictionary in Python, sort of like something that associates with a unique key or like an identifier that maps data or I guess maps values to that specific unique identifier or key, right? So it's essentially just a set of pairs with keys and values that are associated with that key, right? So an example of this would be maybe at UCSC, right? You have everyone here that's a student will have a PID, which is unique to yourself, right? So no one else will have the same PID as you, right? And with that PID, you'll have information regarding yourself that will be associated with that PID, right? So you might have information like first name, last name, major, etc., regarding something that is related to that's associated with your PID, right? And so to look up data, right? Essentially, what you need to do is provide a key to the database, and it should return the value that's associated with that key, right? And one thing I want to mention as well is that most key value databases only support simple types such as strings, right? So going through this example real quick, at the bottom, you have maybe different keys like A1, 2, 3, 4, 5, 6, 7, 8, which could be the sort of key that uniquely identifies you, right? And with that key, you have different values that are associated with that particular key in this instance, right? So for this example, where you have A1, 2, 3, 4, 5, 6, 7, 8, you might have John, which would be like the first name, Johnson, last name, and then your major and graduation, right? So it's basically just a set of entries with key as and key value pairs, basically.
Right. And one thing to note is you can see that in our values, we're kind of splitting the different types by a colon, right? So we have John, colon, Johnson, colon, computer science. Like we have to do that because these key value databases don't have like different kind of properties we can fit data into. It's only like key of string and value of string. So like Ryan was saying, since it only supports very minimal types, we have to like kind of play around with the idea of storing more complicated data. Let's go to the next slide.
Cool. So basically, the next type of database I'll be covering is a document database. And it's a bit more complex instead of the maps that we've been using or key value pairs databases. It essentially stores data using collections, right? And basically, you can think of collections if you've taken like CSE 11 or CSE 12 even as essentially like a class, right? So that class would contain any documents which are essentially instances or objects of that class as entries, right? So a collection would be like any type of data that's associated with one another, right? That's related to one another, right? So going through this example, you have students, right? Which would serve as the collection in this case, or like a class, right? And you have documents, which are specific instances of that collection, right? And so these documents are essentially sort of in the form of like an object which contains a field and the value that's associated with that field, right? So in the student's example, right, you have maybe like a class right, of like a collection, right? And you essentially have a group of documents that are within that collection, right? So going through this one, you essentially have the document of students, right? Where you have the first name is Frank, last name is Tank, and the courses, right? And you can also have subdocuments within a document itself that contains additional information regarding a particular field, right? So for courses, you could have maybe subdocuments regarding the name of the course, the professor of the course, and the term, right? When you took the course. Essentially, this collection would consist of multiple documents that are essentially instances that follow that same sort of format of data. Okay, and the last type of database I want to cover is the relational database, which are essentially a way to organize data and relationships using tables, right? And so basically, you have a table that would be basically like the class of the data, right? So it's essentially like a related set of objects, right? So for example, you have a table called professors, right? So it should contain all data regarding any professor instances, right? Same with courses, right? Any courses that are essentially at UCSD will belong in the courses table. And each of these tables have columns, which are basically like the fields that you want to insert, right? And so fields meaning attributes such as first name, last name, department, salary. You're started for professors, and essentially you're inserting rows, which are specific instances or specific, I guess, instances of data that you want to match the relation or table of fields. So in the professor example, you have essentially you define something, right? Where for a professor, I want to have a unique identifier to identify the professor. You want to associate the first name, last name, department, salary, and year started, right? That's essentially what a table could look like with the different columns, right? And each columns will have a specific type, right? So first name will be bar chart, which is essentially a set of strings, or I guess it's a string, and maybe salary could be like an integer, right? And essentially to insert data, it would come in the form of a row, where it's like when you insert the when you insert data, you essentially have rows that match up with the different columns or attributes of that professor, right? Of that table, right? Where you have maybe in the professor's example, you can insert data such as the first name, where it could be a professor's first name, last name, etc. And essentially, you have like the professor's table will have columns, and datas are basically the rows are essentially like the instances of that.
Cool. Awesome explanations, Ryan. So I will go ahead. So after we talk about database, we'll talk a little bit about SQL. So this will be like the bulk of our workshop. And we're going to be explaining what SQL is. I know Ryan kind of mentioned it before, but how we can use SQL to query these databases. So to briefly explain SQL, essentially what SQL is it's a query language used for kind of managing data within a relational database system. So like Ryan mentioned with the different operations we do against data, we're going to be able to write queries on databases that will be able to create, read, update, and delete data. Those are like the main four operations. And what all a query is essentially some kind of statement we write, like in plain English, that when we execute, we'll get some data or insert some data, etc. So like Ryan mentioned, data is stored in tables. You can think of the tables as classes and the rows as individual objects. But that's kind of how relational databases work, and we're going to explore how SQL can be used to pull data from these tables. So for this workshop, we are going to be actually using a database like on our computer. So as such, we're going to need to set up a database and use a specific, like download some software and interact with that software. So that's what we're going to be doing right now. So we are going to be using the database called PostgreSQL. It's a very weird string to pronounce. People generally call it Postgres, but this is a type of database, a type of relational database that we will be using throughout this workshop to kind of write SQL and execute SQL against databases. This is a very popular database of choice because it comes with a ton of features. It has a lot of documentation, and it's pretty straightforward to install locally. So we're going to be doing that. So what we're all going to do right now is, if you'd like to follow along, we are going to download Postgres locally on our computer. and we are going to install it and get that set up. And I'll go how to do that exactly right now. So I'm going to paste this link in the chat for those of you who want to follow along. And we're going to go ahead and install Postgres. So I'm going to click on this link. For these, I have instructions here. That's for people who, I guess, who are watching or like going through the slides without the content, like me speaking. I'm going to explain all the stuff we have to do. So here we're going to go and click downloads. Right. So once we're at downloads, we are going to pick our operating system family. So I'm part of Windows gang. I'd like to be part of Mac gang eventually, but for now we'll be Windows. We're going to click on this link. I'm going to go back and do it again, but there should be a link right here called download the installer. And we're going to go ahead and click that, and it'll take us to a website here. True Windows gang. I can actually play video games on here. It's very nice. Right. So now we're on this website. We can go ahead and click our operating system of choice to download. We're going to be downloading 14.1. So if you're a Mac user, you can click on this download here, but I'm going to be clicking right here. If you're on Linux, you're awesome. So you can click some of these too, but I'm going to be doing Windows because that's the OS I have. So we'll click that. It should start a download soon. So here you can see download is starting. My apartment has cracked internet speed, so it downloads very fast, but I'll give some time for this installation to finish for everyone else. But essentially, what we're going to do after installing or downloading Postgres is we are going to open this executable. So on Windows, you can kind of click here, or like you can go to your downloads folder and click on that. We are going to open up the installer. And it's actually a very simple process. So don't worry too much if you're like behind somehow. There's like a very few number of fields we actually have to fill in, so it's not bad at all. But yeah, here we have our Postgres setup wizard. We have this magnificent elephant staring at us on the side. What we're going to do is we're going to hit next. We can install it in the default directory for Windows as program files, Postgres 14. We can go ahead and click next. For components, we have these 4 components. You can go ahead and leave them all as it is. If you want the bare minimum software for this, what we're going to do here, you can remove these 2 because we will not be using these in this workshop. We're only going to be using Postgres SQL Server and command line tools. So you can leave the top and the bottom checked. Click next. We're going to store our data in this directory. Click next. For a password for the database super user, this can be any password you want. All of this is when we open our database, we need some way of logging into the database because there's authentication, just so that like other people can't just like access your database. So I'm going to have a very strong password set here. There's no way anyone else will have this password. So I'm going to set that. You can just set it to whatever you remember. But that'll be that. For a port, please select the port number. You can leave it as the default as it is right now. For some of you, it might be 5432 instead of 5433. It does not matter. Whichever port is there, you're going to use. If you're not familiar with a port, that's totally fine. We're not going to be covering that in this workshop. All it is like a way we can connect to the database, essentially. We're going to hit next. For locale, we're going to hit default locale. We're just going to leave this. And then this is just confirming our summary. We're going to hit next. And then here we're going to hit next again. So again, the only real input you should have to do is the 4 checkboxes, deselecting the middle 2, and then entering a password. If anyone is having installation issues, please feel free to drop it in the chat, speak up, or DM me or DM Ryan. We're happy to help. All right, so we'll just finish up our installation. It'll take a few minutes or so. We won't be working with the database right now, so if you want to leave it and kind of let it marinate a bit until it's done, you can do so. I'm going to go ahead and click finish, and that'll be all for our local setup. We're going to interact with our database once we start learning more about SQL. So if anyone has any questions, feel free to DM me. But yeah, let's go back to the slideshow. Cool. So now that we installed SQL on our computer, we're going to go through and look at how we can write queries to actually get data. So SQL queries are generally typed in uppercase. If you've seen SQL before, you might have seen this, that there's a lot of the queries are typed in all uppercase. This isn't because SQL programmers are all angry and want to yell at their computer. It's actually just because there's no syntax highlighting. So in order to distinguish between actual keywords in the language and values that we're providing, we write in uppercase versus lowercase. So some syntax rules for the language. Essentially, the first rule is that all property names are automatically converted to lowercase. So what a property is something like a table or something like a column. Those are all properties. So for example, in this first simple query here, create table students, this will actually create a table called students with lowercase. So if we want to make it so that we're creating something with uppercase, we need to wrap it in double quotes for the properties. And then all values need to be wrapped in single quotes. So a value is something that we are essentially providing as like a parameter or like some kind of filtering that we're doing. So the best way to explain this is with an example. In this first example down here, we have what's called a select query. And what this query does is it kind of reads exactly how it is in English. We have a table called users, and we're getting the first name and the last name from users where the first name equals Bo, right? So you can see that first name and last name are in double quotes because they have a capital N. So they need to be wrapped in double quotes because they're properties. And then users is also in double quotes because it's in capital U. And then first name is also in double quotes again, but then Bo is in single quotes because it's a value. So for this workshop, since we don't want to have to type too many quotes in, we're going to use lowercase columns and table names for our demos. So your Pinky will be proud or happy for you that you don't need to type in so many quotes. Right. So let's talk about creating database tables now. For creating tables, so like Ryan mentioned before, tables are ways that we store data in relational databases. What we can do is create tables with SQL. So this is done with the create table query, which essentially allows you to specify a table name and some columns and their data types. And after that, the table will be created. So in this example here, right, like we have create table, table name, column 1, data type, column 2, data type, column 3, data type. That'll create a table called table name with column 1 with data type 1, column 2 with data type, etc. So every column is required to have a data type, right? And think of it like you have a class in Java, if you've done Java before, or a class in Python, and you have member variables or like instance fields in that class. Every instance field needs a type, right? So it's the very same case here. Every data column is going to need a type. And those basic types are the integer type, the varchar type, and the Boolean type. So I guess you've seen varchar in a previous slide, but essentially there is no string type in Postgres or SQL at all. It is referred to as varchar, which stands for character varying. And essentially, every time we use varchar, we have to specify a length of how many characters the maximum string can have in that column. The convention is that it's 255 by default for smallish text fields, like a first name, like a last name, like a major, like a professor name, etc. they're all going to be 255 convention because that count can be stored in 8 bits. So for those of you who might have done like CSE 30 or like classes where you use bits, 2 to the 8 is 256. So we could store 255 in 8 bits, which is obviously we want to save storage, right? Even if it's like small bits. So with an example here, we have a query that creates a table called students with a first name column of varchar 255, which is a string, and last name varchar 255. So that's going to be a classic query. We're going to be writing a lot of those. If you're going to be doing SQL in the future, you're going to be writing a lot of these. So it's important. So here's an example of the table that we kind of just created in the last, using the last query. We can have this very small table and we can actually insert data, and we'll look how to insert data in the next couple of slides. But here you would have a table with a couple of fields, right? You have like Brad Davis, Peter Parker, MJ. I swear her first name is M and her last name is J, but essentially we have this table. And the thing is, I guess a question we can ask is, what if we want to insert another student named Peter Parker, right? Let's say there's a, I don't want to do No Way Home spoilers, but yeah, if let's say we want to insert another like a Peter Parker in into this table, I guess how can we do that, right? There's no way of differentiating the first name and the last name from a Peter Parker that already exists in the table, right? So if imagine we want to add one more row that's Peter first name, Parker last name, then we have 2 rows with the same exact contents. How can we actually differentiate the two? Spider-Verse spoilers, sure, yes, we could do that. That movie's like 3 or 4 years old. So yeah, imagine there's multiple Peter Parkers. What if you want to add more of those? Well, the way we can do so is something called a primary key. Right, so that might sound a little complicated at first, but what a primary key is simply a way of uniquely identifying in a row in a table, right? So what this means is if I want to get like a specific student, right? Like let's say I'm like on my user profile in a website and I want to get my information, right? I will have a specific unique identifier that will allow me to get my specific information versus anyone else's information. So primary keys are a way that we can uniquely identify a row. So every table should thus have a primary key, right? So we can uniquely identify any row. So because it allows us to store multiple of the same fields, and it also allows storing relationships possible. Don't worry about relationships for this workshop. Relationships is a relational database concept, right? Relational database that allows us to have multiple tables that link to each other, but we won't be covering that in this workshop. For primary keys, we're going to generally have the type serial. In the 3rd bullet point, it says, and they're going to auto increment for each row. So it'll start at 1, go to 2, 3, etc. So now at the bottom, we have this query that's create table students. We have an ID that's of type serial, and then we could specify it's the primary key with the primary key syntax. And then we can do first name and then last name. And now we can have multiple Peter Parkers in our table, right? So this is what the new table would kind of look like. So we can actually store multiple students with the same name, which is nice. One other thing we have with tables is once we create them, we can update them, right? So we can update their structure rather. We'll talk about updating data later on, but here, if we want to alter the structure of an existing table, we can use the alter table syntax. So what that means is we could type in alter table name and then add column data type. So let's say I want to add a GPA column to my students table. I could do alter table students, add GPA, and then like floating point or whatever type there is for decimals. I'm not exactly too sure what the type is, but yeah. We can kind of do that. We can also delete columns. So that's using the drop keywords. We could do alter table name, drop column name. And don't worry about memorizing these. We're going to be going over like actual SQL in a couple of minutes. So you can have these slides up for reference, which is why I kind of mentioned in the beginning to have these up. But yeah, this is alter table syntax. You can add columns, drop columns, rename columns, all that stuff. So like we can drop columns, we can also remove tables. So we can drop tables. If we want to get rid of our students tables entirely and remove all the data in it, we can use drop table students. Very simple syntax. You're generally not going to be doing this unless you have like some very like distributed database that you like create and delete like tables on the fly. But here, this is very simple syntax for deleting a table. Cool. So throughout this workshop, we're going to be doing a lot of interaction with SQL. So the general premise in this workshop is going to be, we're going to be constructing a database for a new fake university called UCLJ, or UC La Jolla, to be able to store data regarding students and courses. So there's going to be a lot of tasks throughout this workshop for building up this database and adding data and querying data. So we're going to be doing that throughout the workshop, but for this part, we are going to be, first off, we're going to be creating two tables. So this is going to be where we're going to actually enter our SQL that we just installed. So I will quickly go over this example, and then we can go to our SQL shell and start doing stuff. So I guess let's have a look here. I'll just go back to the slideshow. What we're going to do here is we're going to create our first table called students. So we're going to create a student table that will allow us to store first name, last name, PID, major, and graduation year. So these are going to be the columns we store. Remember, we also want to store a primary key as the first column. So that's something we're going to want. And then we want to store these in this exact order. And then that'll be that. I'll explain this DT command in a sec. But let's go ahead and open up our SQL that we just installed. So if you're on Windows, you can hit the Windows key. If you're on Mac, I think there's like a search somehow, like Command Enter. What we're going to do is type in PSQL. So this is going to open up a SQL shell that we just installed. So you can hit that and hit run and hit that, like click on it. And then what we can do is, once you see this prompt, and let me know if you don't see anything like this, we can help debug. But once you see this prompt, we're going to go ahead and log into our database. So here, by default, I think it automatically fills in the values for you. So for server, I'm going to do localhost, so I can just hit enter. If this is not showing up for you, you can type in localhost. That's just the server we're going to use it on. For database, it'll be Postgres, so hit enter. For port, hit enter, whichever port you use in the installation. For username, hit enter. For password, you use whatever the password you did in installation. So I'm going to do my very strong password. And then you should be in. So that is that. This is now we're actually in our SQL shell. So what does this mean? This means we can actually start running SQL. So in our shell, I could try to, I don't know if I can increase the size of the screen. I know it's tiny as hell, so I apologize for that. But what we can do here is actually start running, right? Create table queries, right? So I could create table test and then like ID serial primary key. And if I hit enter, it shows I created a table. And then what I can do is do, I think this is /DT. I apologize if you just heard that sound. I have like tap to mute on my / key. So if you hear that throughout the workshop, it's not your Discord, it's me. But yeah, you could type in this command and hit enter, and you see we actually just created a table test. So don't worry about schema, type, or owner. You can see here, this is a list of relations. We have a test relation. So that being said, let's take around 5 minutes to do these two tasks. So I'll actually do, we'll do like 7 minutes for both of these combined. But what we're going to do is we're going to create a table called students, so lowercase students, with these columns, as well as a primary key, right, as the first column. For the column types, you can assume what the column types are based on their description here. And then for the second task, we're going to be creating a courses table with these columns, right? So we're going to have a code, we're going to have a title, we're going to have a professor, a quarter offered, and a year offered. And remember, don't forget about the ID. So let's take 5 minutes right now to go through that. If people need more time, we can do that. But I'll create a timer for 5 minutes, and we can kind of go through that right now. If anyone has questions on SQL, let me know. can pull up the Jazz. I'll keep it low this time. Can't make it. One quick note, feel free to use examples in our create table slides. So I'll leave up a slide right here. This is going to be like this query, for example, it's going to be very useful to have open because it kind of has very similar syntax to what we're looking for. So I'll leave that up. Probably add 1 or 2 more minutes just so everyone has enough time for these 2 tasks. We'll get back at 5:50. So 2 more minutes for everyone. I want to quickly point out this person in the chat who wants you to sub to him or sub. All right, let's get back to the workshop. So hopefully that was enough time for people to write these two create table queries. We're going to go over these right now and explain our thought process behind them. So right here we have two tables, one which is students and one which is courses. And what we're going to do is create tables for both of them using SQL. So right now I have my test table. I'm just going to remove this table real quick so I can do that with drop table test. In my examples, I won't be writing in uppercase because I like my left pinky. I don't want it to get too much harm or also mess with caps lock. So I'll be writing it in lowercase. You can write it in lowercase and syntax will be fine. So yeah, let's do that. So for this table, we have first name, last name, PID, major, graduation year, as well as ID. So let's create our table as such. So we could do create table students with ID and then serial primary key. So that's the type serial and then the constraint primary key. We'll also have our first name as a varchar of 255 for default. Our last name as varchar of 255. And then our PID as varchar. Here we can actually do varchar of 10. For PIDs, I didn't show you any example PIDs, so it's totally fine if you put 255. But most PIDs are like A and then a bunch of characters or a bunch of numbers. So we can just do 10 for this. That's fine. Totally fine if you have 255. We can also do major of varchar 255. And lastly, we have graduation year that is integer. All right. Don't forget our semicolon, hit enter. We have our create table. We could do DT. Sorry about the Discord sound. And then we have students here, right? Then let's go ahead and create our course data table. Let's do that with create table courses. And then we can do ID, serial, primary key, code as varchar. I can do varchar 10 here as well because it's like CSD 12, CSD 100. We can have title, which is varchar 255. Professor, which is varchar 255. Ronak Shah asked in the chat, why don't you do let char or const char? Well, that's because this is not JavaScript. This is SQL. It's a silly JavaScript joke. Yes. All right. Anyways, we have professor varchar 255. We have quarter offered of varchar 255. And then we also have our year offered as 10. Not 10. What am I saying? As integer, right? Hit enter. We have our create table, and then We can do DT again. Sorry for the Discord sound. Now you can see we have courses and students. So for those of you who might have something different than this, I would urge you to make sure your table is like it has this exact schema, excluding the whole bar chart thing, because we will be inserting a lot of data into this these two tables. So it'll be good to have the actual columns, the same columns and everything. Question in chat: does upper or lowercase matter? It does not matter. So if you didn't wrap your table or columns in quotes, then all the uppercase will convert to lowercase anyway. So if you capitalized it, that's fine. If you wrapped it in quotes, what I would do is I would probably delete the table and then remake it with all lowercase. Like you hear the two queries for those here. So just to make sure everyone has lowercase for those, we will do that as such. Question in chat: is there any way to see the column? There should be ways to see columns in the tables. Actually, when we run our select queries on specific tables, when we learn about select, we can do so. I'm going to demo that real quick. This is going to be the most basic select query. If we do select star from courses, you can see here we have our columns that show up here, as well as for students. Cool. So that's how we do create table. I'm going to pass it off to Ryan to talk about inserting data. Take it away, Ryan.
Yep, of course. Okay, so basically, I'm going to be going over how to insert data and instances into the table. And so basically, the general syntax for this is essentially insert into basically whatever table name that you want to insert data into, different columns that you want to insert, that you'll be inserting data into, along with the values that are associated for that column, right? So let's say you have column 1, column 2, column 3. You essentially, the values, value 1, value 2, value 3 will correspond to the column that basically it's in order, right? And whenever you have a column that's not specified directly into the insert command, it will just store a null value. An example of this would be the insert into students, where you specify the columns of first name, last name, PID, major, and graduation year. And you can sort of see how the values sort of are aligned and sort of correspond to where the column is located, right? So you see how the first column that is in there is first name, and that's why you in the values you have Liz, and then the last name matches up with Frizz, PID matches up with A1, 2, 3, 4, 5, 6, 7, 8, 9, major matches up with data science, and graduation matches up with 2025. And the ID column will, you go back real quick, will just be, once you basically insert stuff, I think Shravan was covering the whole concept of primary keys. And essentially, when you insert data into the table, you'll have by default an ID of column, ID column, and with a value of 1, etc. And it'll just increment. So just to make sure that it's unique. Okay, and so basically, I think we went over the example of the standard way to do it, right? Where it's like you have basically all the columns corresponding to the table, and you're inserting values that match up with that, right? But here's another example where you have basically, let's say you don't know the PID of the student that you want to insert into the student table, right? This is an example of where you just don't include that in the columns. If you look at the query right there, you can see that PID column is not actually in the query. And so that's why when you're inserting values, you have no PID value that you're inserting, right? And there are also cases where you can insert an explicit ID, right? So essentially, let's say you want to have a student in there with an ID of 3, which is unique to that student. And you can just specify which would be like the first column that you're inserting into, which would be like a value of 3. And you can also follow like a different format where instead of specifying the columns, you can just insert values directly as long as all the values that you're inserting has a column associated with it. And also, just as a quick note, if you have something in the table that already has a unique ID of 3, your error is going to be thrown, right? Because the whole definition of a primary key is that it has to be unique, right? And if you want to try to insert value or students that has an ID of 3, which already exists, then you're going to have an error.
Right. I'll take it away from here. So what we're going to be doing in this workshop is populating our tables that we just created with 1,000 or plus rows of fake student and course data. So while this might sound like a lot of data, right, like on your computer, it's actually really, really small. 1,000 rows, I kind of calculated, is about 200 kilobytes, which is pretty small considering the amount of storage our modern computers can store. So it's actually not that much data. So we're going to be working with that data in this workshop and doing operations on that. So what we can do is actually click on this link in the slides, and that'll take us to a SQL query that I wrote that we can actually insert a bunch of data with. So let me post this in the chat as well, right here. So what we're all going to do is we are going to copy every line of this this file right here. So I can just drag all the way down and copy that. You can see there's just a bunch of insert into queries that with randomly generated names and less randomly generated courses. We'll go into the courses in a sec. But yeah, we have all this data that we're going to be inserting into our database. So you can see here, like kind of the syntax Ryan went over just now. We have that. So what I can do is head over to my shell, and I could straight up just paste this code. So for Windows, that'll be Control V. For Mac, it might be Command V. But if I hit paste, you can see there's a ton of queries that are running. So this is going to take a couple seconds, but all this is going to do is just insert the data into our tables. For the last one, you might have to hit enter because there's no new line. But yeah, there we have our data inserted into our tables. So that's about 1,000 students, right? I think it's exactly 1,000 students and about 40 courses. So if you all are curious on how this was generated, I can like quickly show that. I do have a repo here with some Python that I wrote for generating these queries. It's just using string syntax in Python, but that's how we randomly generate those. So yeah, what we're gonna do is throughout the workshop, we'll be going over we'll be using this data directly, and we'll be looking at this data and exactly how we can operate with this data later on. For now, we can just copy it in our code, in our shell, and leave it as that. That was a quick interlude. I'll give it back to Ryan to talk about selecting data and reading and analyzing data.
Awesome. So if you can go to the next slide, basically, using our current SQL knowledge, we essentially set up a storage mechanism for data to be written and inserted. But basically, the question is, how can we actually read and manage the data that we have in there, right? And so more importantly, we can answer some questions like how many courses are being taught in one quarter, what professors are teaching a specific course, how many students are majoring in computer science, and when is Timmy graduating. This is essentially like, basically what you do is for reading and analyzing data, you can have a set of constraints in there to essentially filter through the data to extract exactly what you need. Okay, so this is an example of essentially the syntax for how to read data, right? And so basically you'll have the select command, which is, and following that, you'll have the column names, which you want to select from, the different columns that will essentially be in the result of the data that you're reading from, and what table name, right? And then the where, essentially, the where clause will essentially be sort of the filter for filtering through the data to select particular rows that you want in your results, right? And there's tons of ways to filter data by conditions, which will be covered in the next slide. And basically, when you're selecting different columns, you can specify which columns to specify, or if you just want to select all the attributes, right, you can also just use a star, which basically is like a shorthand for select all columns. And yeah. Okay. And so I'll just be going through some of the use cases for the where clause. And basically, this is just basically another filtering mechanism for reading, selecting data, right? And so you can have string matches where some property will equal a value. You can have classic comparisons where like property is less than a value, greater than a value, etc. So this could be like maybe if the number of students are greater than 3, for example, or the number of courses or professors is greater or equal to 10, etc. And you can check for whether an element actually exists in your data. So let's say maybe like you want to check for the existence of a professor who has a name of John or Porter or something. And you have logical operators where basically you can chain stuff, where such as like you can basically use like Boolean expressions such as and or not. This is the classic ones that you've seen. Okay, so I guess I can go through some examples of, I guess, use cases of the filtering mechanism, such as where, right? And so for a single select, the first one is basically you're selecting all, right? All columns from the students where the first name is equal to Grace. So what this will essentially do is essentially think of this as sort of like a for loop where you're going through each of the rows in the student database or table, and basically you're looking at the first name column, right? Essentially, there is an attribute called first name for each of these rows. And whenever the first name is equal to Grace, you'll essentially be extracting that and putting that into the final result that you're returning. Next example is you're selecting the first name and the last name. So basically what the final result will look like is essentially a table consisting of first name column and last name column from the students table, right? And so like I explained for the early example, you're essentially going to go through each of the rows in that students database where major is equal to computer science, right? And so in a case where a particular row has a major that's equivalent to computer science, you'll essentially take that row and take the first name and last name of that specific row where the major was computer science, and we'll essentially like insert that into like the final results you'll have. And also you can chain logical operators where you have and, or, etc. And so in this example, you're selecting the PID column from the students table where the first name is equivalent to Dom and last name is equal to Cobb. So basically you have to match both of these conditions to be in the final results, right? And so you'll be going through each students in the students database, each row. And whenever the first name and the last name is equivalent to Dom and Cobb, that's will be included in your final answer, right? If there's a case where the first name is Dom and maybe the last name is something else like Parker, that won't be included in your final results. There are a few pop culture references. Holler if you see them. Okay. Okay. Comparisons. Another example would be essentially like comparing using comparison operators. So basically, in this example, right, you will be selecting all the columns from the merchandise table where price is greater than 500, right? So essentially, there will be a column or an attribute in the merchandise table consisting of price, right? So in each row, you'll be saying, hey, is the price greater than 500? If so, include this entire row in the final answer, right? And chaining logical operators where basically you have maybe you're selecting just a state from the census data where the population is less than, what is that? Seems like it's 40 million, right? And the votes is greater than, greater or equal to 2 million, right? And so basically you're going through census data and you're checking the population column. And if it's less than 40 million and the votes column for that particular row is also greater than 2 million, you'll essentially have that in your final answer, that particular row.
Cool. So I'll take over for a bit. Essentially, let's just mess around a little bit with the data we just pulled. So we copied a lot of data just now. Ryan just went over a bunch of ways we can interact with that data. So let's go ahead and do that right now. So let's see. So we have our students and our courses table, right? So let's actually just run a simple select query on our students. So I could do select star from students to get every column and every row for the students table, and I'll return me this. So this is a lot of data, but essentially it's just all the first names, last names, PIDs, majors, graduation years, and then I can hold enter to scroll through all of it. There should be 1,000 of these, so I'm not going to go all the way through, but yeah, a bunch of first names, bunch of last names, all that. Different majors, right? We have CS, computer science, computer engineering, data science, cog sci, math CS, bunch of majors. We can do the same thing with courses. So we can view our courses table. We have a couple fake courses here and fake professors and fake titles. So we have ECE 15L, which is binary lab. CSE 143, which is computer architecture, PC builder perspective, CSE 12L, reversing linked list lab, CSE 13, mediocre data structures, a bunch of random courses. We also have different professors who teach them, right? Arthur Fleck, Leland Stanford, Blueface, Joma Tech, bunch of interesting professors. You see here, we actually only have 40 rows, so it's not as big as the last table, but here's a bunch of fake data we're gonna be working with. Shout out to Stanley Lee as well, our ACM president, for teaching as well. All right, let's do some filters now. So what we can do is maybe, like, we can get all the professors that are like currently teaching, let's say. So let's say I want to get, right, like all the professors who are currently teaching. So right now the quarter is what, winter 2022. So I can do select professor from courses where quarter offered equals, remember, single quotes, right, because value, winter, and year offered equals 2022, right? Do we have anyone? Yeah, we have just Blueface, who's teaching this quarter. Nice. Let's look at 2021, right? We have Stanley Lee. Maybe 2020, we have Arthur Fleck and Leland Stanford. Right, so we could filter kind of like that, right? We showed chain operators using where. Maybe we want to get, and year offered is just greater than 2019, let's say. So let's say like any professor who taught in winter outside after 2019. Right here we have a couple. We have Carl Anthony Towns, Blueface, Stanley Lee, all these people. Shout out if you know all these people. It's a very spread out list of professors. All right, so yeah, that's our kind of where clause. We can do the same thing with the students table, right? I could select maybe like first name and last name from students where graduation year equals 2021, right? Everyone who graduated last year. There's a ton of people who graduated last year, right? So yeah, that's kind of how we do some basics into SQL select queries. I will hand it back to Ryan to explain about some of the more complicated things we can do in the SQL select clause.
Awesome. So, okay, basically we'll be going over the as clause, which basically allows you to specify a temporary name for a column, right? So it's essentially an alias, right? So let's say you have maybe select first name as name from students. So essentially, let's say you didn't want any last names and you wanted, basically when you're extracting results from the select column or the select query, you'll essentially be getting a table where if you selected first name as a column, that specific results column name will be associated with the column that you specified, right? But let's say you want to have first name and set it equal to, or have that results table display a different name or an alias for that. That's essentially where the as clause comes in. And you can specify a different name for a column that you want to select. And this is pretty useful for when you have aggregate functions, which are essentially like performing computations on multiple selected rows. So basically, let's say you have like 10 rows, for example, of different students, and you want to get the number of students that you've selected, right? So you can use common aggregate functions such as count, which would count the number of students that you've selected, or you can use maybe sum, right? Maybe you want to do like a sum aggregate function on the number of, let's say, courses that a student is taking, for example. So let's say, essentially you'd go through like all the rows and basically sum the whatever column value that you want to sum, right? And so example of this would be like select count star from students where first name is equal to Maokai, right? So basically you're going to go through this step where you're selecting all the students where first name is equal to Maokai, right? So essentially going through the entire table and checking where first name is equal to Maokai. And if it is, essentially you have that in the results, right? And so your results table, right, will essentially consist of instances where first name is equal to Maokai, right? And what the select count star is doing is essentially counting the number of essentially rows you have in that database, right? And so let's say you have like 10 students that have a first name of Malachi, that would essentially return 10. Another example I can go through is select max price from bicycles where color equals blue or color equals Vanta black, right? And so like I sort of specified earlier, you're essentially going to go through the bicycles table and checking all instances where the color is equal to blue or color is equal to Vanta black. If either of those conditions are met, you'll essentially have a results table, right? Consisting of all the rows that met this condition, right? Once you have that, you'll essentially be going through you're looking at the price column, right? The price attribute of these bicycles, and essentially taking the max value of that, right? And that's essentially what it'll return.
Cool. Thanks, Ryan, for that explanation. So what we can do now, so now that we know some basic SQL select syntax, a lot of S's, we can actually start answering some beginner questions and kind of do some analytics about our data. So I guess let's go ahead and take some time and answer these questions. So feel free to drop your answers in the chat or speak up if you want to say your query. But let's go through these one by one and kind of write a kind of query that can answer these. So for the first question, let's say we want to answer how many courses are being taught in winter 2021. Does anyone know a query we can write here using the stuff we just learned that can answer this question? Feel free to, I guess, speak up or drop it in chat. If anyone has any questions, let me know. Okay, maybe we can walk through this first one. Let's see. So if we want to ask how many courses are being taught in winter 2021, well, in our courses table, we know we have a quarter offered field and a year offered field, right? So if we go to our table, I can open up here, right? Select star from courses. I can enter, and I can see we have, right, quarter offered, year offered. So if I want to count all the courses that are being taught in winter 2021, then I know I have to do some kind of filter where quarter is winter and year is 2021. If we want to count how many courses there are, like I just said, we have to count it. So we can use the count aggregate function right here, kind of like we did here in this example. Instead, we're doing two filters. So what this would look like is select count of star from courses where quarter offered equals winter and year offered equals 2021. Turns out there's only one course being offered in winter 2021. Maybe we can get the exact course that's being offered, just if we're curious. All right, it's computer architecture taught by Stanley Lee for winter 2021. Thank you, Stanley. Right, so that's for the first question. Does anyone have any questions on that before we move on to the second one? Cool. I'll move on to the second one. If we want to ask which professors taught CSE 13 in 2020, we can do actually a pretty simple select query. We don't need any counts or averages or any aggregate functions. What we can do is just do select professor from courses, and then let's see, CSE 13 in 2020, where code equals CSE 13 and year equal, or year offered equals 2020. Right, so we have three professors that taught CSE 13 in 2020. We have Arthur Fleck, Blueface, and Leland Stanford. Cool. For our last query, we have how many students are not majoring in computer science. So here we have a not operator. So this is kind of a new one that we haven't used yet. So if we want to see how many students are not majoring in computer science, actually the not operator in SQL, I believe, is this, the two brackets. So what we can do is select the count of all the students and then just say where major not computer science, right? So what we can do is select count of star from students where major is not computer science. Right, and we get 818 are not computer science. That's a pretty good distribution for non-CS majors, right? Out of 1,000. I guess because it was randomized, because everything should theoretically have a 200 count, but yeah. Cool. Any questions on the select queries we learned so far? All right, if there's any questions, feel free to jump in the chat. Cool. Hand it off back to Ryan to talk about even richer analytics we can do.
Awesome. Okay, so basically the previous queries only really gave us insights into data from specific parameters that we desire. But what if we want data and analytics to answer more generalized questions such as how many courses are taught during each quarter? How many courses is each professor teaching? Give a roster of all currently enrolled students sort of alphabetically and find the average graduation year across all majors, right? And what we'll cover in the next few slides will essentially answer some of these questions. Okay, and one of the biggest sort of useful mechanisms for accomplishing this is the group by clause, which is basically you're allowed to group rows of the same value of a specified property together, right? So let's say you want to group all students with the first name of John, right? You're essentially able to do this with the group by clause. And basically the general syntax for this is essentially one thing I want to actually mention before we continue with syntax is some of the rules for group by, right? And so each column, when you're specifying, must either be aggregated or grouped by, right? And so what it means to be grouped by is essentially the category or specific attribute that you're trying to group into categories by, right? So for example, if you want to group, by the first name, for example, right? You'll essentially put that in the group by clause where it's a group by column 1, which is essentially the column or attribute that you're trying to group into categories by, right? So maybe for first name, you can do like group by, or I guess I can give a quick example where you maybe select column 1, aggregate column 2 from table name group by column 1. And maybe you want to group by the first name, right? Essentially what we'll do is go through the entire table and select all attributes with first name that are equivalent to one another, right? So we'll probably specify a group by together first names that have equivalent to each other. So maybe like there's like 5 kids that have the first name of John. That will essentially be grouped by into a section. Another group by would be maybe like all first names with name of Patrick. Essentially, once you have these different groups of values that are equivalent to one another, you can essentially run different aggregate functions on other columns that haven't been grouped by. So what I mean by that is essentially you have, let's say you have a simple table, maybe a first name, or I guess name, and the number of courses one is taken, right? So basically, if you're trying to group by name, for example, right, essentially go through the entire table and go through and select different groups that have the same value, right? So all first names of John will be grouped together, etc., right? But since we didn't group by the other attribute, which is the number of courses in this case, it doesn't really make sense to actually put that in the actual results, right? So what happens if you have like 5 dudes with the name of John, right? How would you essentially display each of the number of courses that one is taking, right? It doesn't really make sense because it's not grouped by the number of courses, right? And so what you want to do is essentially have maybe like some sort of aggregate function, right? That can specify for that other attribute, right? So an example of this could be like, let's say, find the total sum, right? Sum of number of courses that,
Yeah, we can actually just look at an example here. I know coming up with examples is very hard.
Yeah.
But yeah, feel free to use this one right here.
Okay, cool. So it seems like there's an ID and item name of orange apple. And it seems like there's a count, right? Say we have these rows in a very simple orders table, right? Essentially what the orders table will consist of essentially is ID and the item name, right? And so this query essentially is selecting the item name and grouping by it, right? So essentially you'll be going through this table and selecting all item names that are equivalent to one another, right? And so you have orange, apple, and peach, right? You can essentially have three distinct categories of that, right? And once you've been grouped, you can essentially do an aggregate function of the ID, right? Essentially the number of IDs for that particular group, right? So in this case, you can see with the item name of orange, you're essentially seeing how many IDs. You have 1 and 2. And that's why in the count, you have a value of 2, right? Because you're essentially doing an aggregate function of count and counting all instances where you have an item name of orange, right? Essentially, and you're going through each of these groups where you have orange, apple, and peach, and essentially including the count of that in the results table right there.
Cool. All right. So awesome explanation, Ryan. I think in order to solidify this even more, let's take a look at some group by examples so that we can understand this a little more. Because the important thing Ryan mentioned is that group by allows us to generalize data or different things about data that we couldn't have done with just using where or using filtering. So like Ryan, we showed in the previous example, let's say we wanted to get the number of every item in our table, right? How many of each item there are in our table, right? The keyword is each. How many of each item? How many of every item, right? How many of those are in our table? We can use aggregate functions and group by combined in order to count the number of items, like individual items are in each, are in the table, and then group them by the item name so that we get orange 2, apple 3, peach 1, which is actually counting all the items. So we can do this something very similar in our SQL right here. So let's go to our students table and kind of go through some group bys. So in our example, let's do, I guess you can kind of see the queries right here. I didn't even know I had speaker notes in the first place, but yeah, let's do that here. So we'll run these 4 queries and kind of see what's going on here. So first, let's just get all the first names from students, right? Let's just do that. Here you can see we just have a giant list of first names. A lot of these will be duplicates, right? Because we have a lot of duplicate first names, right? We could have 5 Johns, like 10 Mirandas, etc. Then what we can do is this: if we want to count the number of first names that are in the entire table, right? We could do select count a first name from students, right? This should just yield 1,000, right? Because there's 1,000 first names in our table. Now what we can do is in this first query, right, select first name from students. And then if we want to add group by first name, right, with no aggregate right now, we'll just do group by. We get a giant list of first names, but one important characteristic of this is that there'll be no duplicates because all duplicates will be grouped by, right? They'll be grouped together, which is what group by means. Right? So all like Kimberlys are now in this one Kimberly entry, right? But this doesn't yield any useful information, right? What's something more interesting is how many of first names are in our table, right? So like, let's say we want to count first, do first name and then count a star and enter. Now we can see that all the Edwards have been grouped, but with our count column, they have been aggregated so that all the rows are being counted and now a count is yielded. So now we know that in our school, in UCLJ, we have 2 Edwards, 1 Peggy, 4 Susans, right? We can keep going. Let's see if there's like any, 25 Roberts, right? A lot of Roberts. We can kind of scroll through this, 10 Charleses, etc. You get the idea. 15 James, 7 Daniels, 3 Roses, etc. So that's kind of how that works. If we want to add yet another dimension that we group by, we can actually do first name and last name and count from students group by first name. I remember the rule for group by is every column we specify needs to be either group by or aggregate. Otherwise, SQL doesn't know how to combine rows together. So here we have to do group by first name, comma, last name. And if we enter, there should be, most of these should be 1 because there's a very low chance that people actually have like the same name, like the same first and last name. I'm gonna cheat a little bit and sneak peek the next query we're gonna look at, which is order by. We can actually do order by count to see if there's any people. We can do descending with same, but it doesn't look like there are. They're all ones. But we're gonna go over order by in a sec. But yeah, that's kind of how group by works. Hopefully that clears some stuff up a bit. All right, we will go back to Ryan with order by.
Cool. Basically, we've covered group by, and basically, I think Shravan quickly touched up on it, but basically what order by allows you to do is essentially order your results in some specific order, right? So let's say you have an integer value, right? And you want to order by an ascending order. You simply just add the order by for that column, and it should order your results based on that column value, right? So for example, let's say you want to order by, you have like a group by function, and you want to order by, let's say, number of students that are, let me think, the number of courses each student is taking, for example, right? And essentially what order by will do is essentially display results in sort of like a chronological order, right? So default, if you don't specify anything else for the order by column, such as DSC, it will just take the ascending order by default and essentially order things in chronological order where you go from like 1, 2, 3, etc.
Awesome. Yeah, I guess that was a very quick explanation. But yeah, let's actually, now that we know we have all these, oops, let me go back. Now that we have all these tools under our belt for querying for data, we can actually do a lot more richer analytics with SQL that we couldn't have done before. So I guess what we can do now is let's take 5 minutes, and what we can do is try to answer each of these questions in our SQL shell, right? So you don't need to type it in the chat or like speak up. What we could try to do is just take a chunk of time to just try out and like answer as many of these questions as we can. So to go over these questions very quickly, we have like how many courses are taught during each quarter, right? So this will be just fall, winter, spring. Don't worry about year yet. So this will be like every fall, every winter, every spring. And then we'll look at each unique quarter, like fall 2020, fall 2021, right? So think about how we can kind of do that in SQL. Let's look at how many courses each professor is taking. And then for the third one, give me a roster of all the currently enrolled students sorted alphabetically. So by currently enrolled, I mean that their graduation year is not in the past. So I guess everything greater than or equal to 2022 graduation year. And lastly, let's find the average graduation year across all majors. So let's take about 5 minutes. If you can't get through all these, totally fine. But let's just take some time to think about how we can write SQL for each of these queries. And then after that, we will, I'll go over exactly how we can write these queries and my thought process with that. But without further ado, I will whip up the jazz music again. So we'll take some 5 or so minutes to do that. A timer as well. Alrighty, let's have a look at these 4 queries. So no worries again if you haven't got through all of them. We'll just walk through each of these together and go from there. So for the first query, for the first question, I guess, we have how many courses are taught during each quarter? So a big giveaway that this is a group by query is that it says each quarter, right? So we care about a generalized view of all quarters, right? So fall, winter, spring, and understanding how many courses are being taught during that quarter, right? So how many courses, I guess, are there for like for each quarter, and for the next question, each quarter and year. So we could go to our SQL and type in exactly such. So we want, right, we want the number, how many courses are taught during each quarter. So we want to group by quarter, and then our aggregate should be, what the heck? Our aggregate should be the actual course, right? So let's do select quarter offered, and then count of star from courses group by quarter offered. Right, so here we go. We have 13 courses in spring, 19 in fall, and 8 in winter. Right, so how many courses are being taught during each quarter? Again, if we want to answer each unique quarter, so we want the quarter and the year, we would just simply add year offered here, right, for our column. And then for our group by, we also want to add year offered. Now we can see that we have a more interesting analytic, which is how many courses are being offered each quarter, like actual quarter, right? If we want to group it by, or if we want to order by by count, right? If we want to get ordered by count. We want to order by count descending to get the quarters that offer the most, right? We can see we have spring 23, fall 20, fall 21, fall 22, etc. If we want to sort it by the quarter offered, then that gets a little more interesting because if we're sorting it alphabetically, then it's like spring, fall, winter. Or no, sorry, it's what am I saying? It's fall, spring, winter. So that's not exactly in alphabetical order. So we'll leave it here for now. For our second question, we have how many courses is each professor teaching? Right, so this is going to be another group by because we have each. So we want to count the number of courses and then we want to group by the professor, right? Because we want to look, we're interested in each professor. So here we have select professor and group by, or sorry, not, and count of star from courses group by professor. Right, so here we have a list of professors and their counts. Again, we can order by count descending. And we see that Carl Anthony Towns is an NBA player, is teaching 7 courses. Blueface, the hip hop artist, is teaching 5. Joma Tech 5, yeah, etc., etc., etc. Ada Lovelace is teaching only 1 course, even though she's like the queen of CS, which is kind of unfortunate, but it's okay. For our third question, we have give me a roster of all currently enrolled courses sorted alphabetically. So we want, sorry, all enrolled students sorted alphabetically. So here we're going to look at the students table now, and we want all the enrolled students sorted alphabetically. So what that means is, right, we go to our students, we have their graduation date ahead of 2022 or equal to 2022, and then we want to get their first and last name and then sort those, right? So what we can do is use select first name, last name, and then that's all we want, right? Because this is not a group by, we're not grouping by anything, right? I don't know why this keeps going away. We're not grouping by anything, so we can do first name, last name from students, where graduation year is greater than or equal to 2022, and then we can order by first name, comma, last name. Ascending is by default, so we can omit it. But here we're ordering by 2 columns, which means we sort by the first column. For any ties, we sort by the second column. So I guess this is not like actually, I guess it is actually, yeah, I guess it is in order. Actually, not entirely, right? Because like here we have our first name, like Amy is ahead of, like her last name shouldn't be, right? It shouldn't be ahead of the other people, right? So like this is not like exact sorting algorithm. But I guess if we wanted that, we could sort by only the last name. I guess that's how attendance is taken. I forget how attendance is taken these days. But here we're sorting by first and last name. If we want to sort just by last name, we could do the same as well. All right, order by last name. Right, so here we have all the A's up front. And then if we want to order by first name, for some reason, we could do the same thing. But essentially, this is using where and order by in the same clause. Okay. For our last question, we have average graduation year across all majors. So here we're using the average aggregate function, and then all majors, I guess each major, same thing, we know it's grouped by, right? So what we can do is we can do select the major, right? And then what we can do is do average graduation. So this is average graduation year from students, right? Grouped by. So the average graduation year of computer science is 2021.80769. Okay, that's not very useful, is it? I guess here we do have the graduation year for every major, but it's in a format that we don't really care about. We'd rather care about a whole number. So it turns out in SQL, you can actually round numbers. You don't need to memorize the syntax at all, but essentially what we could do is do round average and then specify how many decimals we round to. If we do 0, it's 2022. I think if we do 1, it'll be like that decimal, etc. So that's kind of how we can do that here. Any questions on richer analytics? Alrighty, excellent. I will take it over from here. We have 15 more minutes. We'll try to get through everything we can. Should be able to. Quickly to cover up updating and deleting data. Essentially, we looked at reading and writing data. We can also update and delete data. The syntax is very similar to stuff we've already seen. So for update data, for our update query, we have update title name, set column equal to new value, column 2 equal to new value where condition, right? So kind of intuitive, where we have, if we want to set a specific column to a specific value where a condition is met, we can do so. So for an example, we could set our graduation year, update students set graduation year to 2024 where ID is 10, right? If a specific student wants to update their graduation year, they can do so. And that'll be the query that's ran, right? For courses, if I want to update CSE 13, which is mediocre data structures, into CSE 14, which is decent data structures, I can do that with this query as well, and the second one. And then lastly, with our third one, if I want to like increase the price of a merchandise I might be selling, then I can do that with this increment operator here. Again, very intuitive, similar to the stuff we've seen before, but that's kind of how update works. With delete, it's actually very similar to the select query, but instead we use delete from. So if we want to delete data from a database based on filters, we can do so. So the filtering is the exact same mechanism as the select query or the update query. So if we want to delete from students where ID is 10, right? Let's say that student like doesn't attend the school anymore, or like dropped out, they can delete the students. If we want to delete all students who are graduating in 2022 in year computer science or major computer science, we can do so. If we want to remove all merchandise where a product name is Algorithms 3rd edition, we can do so. You kind of get the idea. One trick I learned from the industry, I guess, with delete from is, let's say you're in your database and you actually need to delete some data. Like maybe some malfunction happened and too many rows got added and you need to delete those rows. Delete from is a very dangerous query to write because there's no like rolling back the changes you made unless you made some kind of backup, which we didn't cover in this workshop. So if you want to know exactly the data you want to delete, what you can do is actually write a select from query with the same where conditions that you specify in your delete query, and then see what all the results are. And then what you can do is just remove the select from and change it to delete from. And then that'll delete the exact same rows that you selected. So that way you know exactly what rows you're about to delete and like can visually make sure that everything makes sense. All right, I can execute my delete, and then boom, I deleted all my data that I actually want to. That's a quick tip. Cool. That's everything we had on SQL. So hopefully that was kind of interesting, or for those of you who might not have seen SQL before, I'll kind of tell you, like, I'm in CSE 132A right now, which is a database course. And what we went over just now in like the last hour and a half is what they covered in like 4 or 5 lectures, which are each an hour and 20. So we just sped ran a lot of this class. So if some stuff is very confusing still, that's totally fine. We did give a very brief intro of SQL. It's actually funny because I taught this workshop last year too, and now I'm taking 132A, and it's like, hey, a lot of this is like kind of review. So for those of you who are planning on taking CSE 132A, congrats. You don't need to attend the first 5 workshops or first 5 lectures. But yeah. It's actually also interesting because in that class, you learn how to query data outside of just SQL. There's very weird and interesting ways of querying data with something called relational calculus or relational algebra that is very math proof heavy, but is like focused on correctness. So there's actually different ways to query data. People, 99.9% of the time, relational databases use SQL for that. But there are actually other ways to query data out there. All right, so for the last 10 minutes, let's talk about what's called object relational mapping. That is quite the words we have here. So let's kind of break down what this is. So I hate to break it to you, but actually everything you just learned, you probably might not do that often. What do I mean by that? So in the industry or in your projects, you don't actually write SQL yourself. Like 90%, 95% of the time. Because if you think about it, what we just did is we wrote SQL queries in a shell to add or remove data, right? So let's take like our auction system that we worked with. If we want the auction API we wrote to add data to a database, like we as humans are not going to be like sitting in front of the computer meticulously typing in every insertion and deletion that happened, right? No, we're not doing that. We want some way to write this in code, right? So that way, any like code that we write in some kind of API or some kind of backend can actually call the database and do some specific queries against that database, right? Because we humans don't want to be doing stuff. Like software engineers are professionals at not doing stuff, right? We automate everything. So again, for SQL, we don't want to be in front of the computer at all. Like for big applications like Google and Facebook, like google.com, facebook.com, there's like billions of rows being manipulated per day. So there has to be some way to automate this, right? There, it turns out there is, and that's by something called an object relational map, or ORM. So ORMs are essentially packages in your code that provide functions to perform database operations. So what that means is, let's say I have a package ORM called ORM, like in this example, these 3 lines. There's actually functions that they provide to us called like find, insert, create table. And we can use actual code to pass in a table name as a parameter, or a filter as parameters, and insert as like a table name as parameters again, like different data. All of these as like actual code rather than SQL, which is like a query language. And that way we can actually do stuff via programs, right? So our API that we wrote last workshop, or like, let's say you write a script that updates a database, that you can run with like Java and then like script.java, right? And hit enter, and that would actually make a database call. You would use an ORM for that. So what ORMs do is essentially they first form a connection with your database, right? Like we did in the beginning of the workshop, we kind of logged into our database via the shell, right? We did server localhost port 5433. We essentially logged into our database. The ORMs have to do the exact same because it's inside your code, right? And I'll show examples of what this looks like if this is a little confusing. But essentially what we need to do first is form a connection with our database, pass in the database credentials via our code. And then after we do that, like in this last slide, we can see we have some functions like find, insert, create table. We can use the code that the ORM provides to perform database operations. The ORM will then convert those those functions into raw SQL and then execute the SQL against the database. So the ORM is the one that's actually doing and executing the SQL, not us. We are simply using the ORM's function that gets extracted into SQL to do so. So I'm going to have a couple examples on the slides. The next couple of slides. This is with the ORM called type ORM, which is a Node.js plus TypeScript ORM, which is basically JavaScript. So if you write a backend in JavaScript, then you will use an ORM like type ORM. For those of you who might have attended the workshop, the last workshop on APIs, this is the same stack we used for the auction house. Let me get some water real quick. Give me a sec. All right. So I mentioned this briefly on the last slide, but in order to connect to a database, an ORM has to specify these 5 properties, right? So it's the same properties we worked with when we were logging into Postgres for the first time. The host, which is localhost, username, which is Postgres, password, which is my super strong password, which was password, the port 5433, and database name Postgres. So in order for an ORM to connect with a database, it must know these 5 properties. So in this example, here there is a function provided by Typeform called create connection. And what this does is it allows us to create a connection object by passing in these parameters, right? So here I use 5432 and database auction as an example from our auction house. But essentially, if you look at Typeform's documentation, you can look up that there's a function called create connection, and you can create a connection like that. So once we have this connection, then we can start executing stuff with that connection, right? So here's one concept before we look into the connections and actually calling find and create and insert and all that stuff. There's one concept that's very specific to ORMs that are not actually like part of SQL that I want to cover, and which is models, like database schema. So in order for ORMs to actually do the job that they need to to insert data or create data, they need some kind of type that defines what that data looks like inside code, right? So in SQL, we wrote a table that has a schema, right? It has a bunch of columns. It has a like different data types for those columns. The ORM, since it only exists in the code, it needs some way of knowing that database schema inside code so that it can use the proper types. There's like type generation when you're using like an IDE, right? If you're using VS Code and you're coding it up, you have automated like type checking, that kind of stuff. And what we can use is something called models. So models, all they are something, some schema in your code, right? Like a class, for example. We'll look at an example in a sec. That we can define columns and column types for an entity, right? So if we go back to our option example, we had users in our options. And this is an example of a database entity. So ignoring the very TypeScript heavy stuff going on here, I want to bring your attention to the three important things, which are the column names, right? So we have ID string, username string, balance string. Those are the columns and their types. So this is in TypeScript. This is how you define types in TypeScript. So like in Java, right, you have like private int balance, or like private string username, or private int string ID, right? It's the same thing like here in TypeScript. But what we then do is use our ORM. Our ORM will have some kind of functionality for converting these into actual database columns, right? So for in type ORM, we have what's called a decorator. And you might have seen this in Java with like @override. But we have something called a decorator that marks the class as an entity, and then actually makes it so that these columns are marked as actual database columns. And with this top one here, primary generated column UUID, this makes it so that that ID column is a primary key, right? What we talked about earlier in the workshop, but also that it's the UUID generated column. So in our example we used previously, we looked at serial type, right, which is incrementing integers. If we want more secure ways of storing ID, we can use something called a UUID, which is universally unique identifier, which randomly generates a scramble of letters to use as the ID. Because if you use the ID as just an incrementing number, then a hacker or some user might know how much data you're actually storing based on the ID, right? If you have an ID of 40, then I know at least 40 elements exist in your table, right? So that's not information we want to provide to the user. So we can use a UUID instead. Then finally, we can actually execute database calls using some kind of function. So don't worry too much if you don't know what the syntax going on here. This is TypeScript. The key idea I'm trying to provide to you is that instead of using SQL, we are using ORM functions, like actual code, to execute instructions for the database, to execute SQL. So again, if you're not familiar with con.manager.save, like don't worry too much about that. That's very specific syntax to this type of ORM library. The key point is that we can actually pass in a object like username SM Hariha, which is like my UCSD thing, and balance 50. And then we could just do con.manager.save, right, with the connection we created before. And that'll transfer this query, this function into an insert into users values thing query, right? So the ORM converts this function call into a query, which then gets executed to the database. So that's how we can actually add data to a database via code, which is very important. Cool. I'll let that marinate for a bit, but this is a very important concept. If you plan on doing backend engineering and you're working with databases, you will be using ORMs. Like it's a guarantee. There's just different ORMs that exist, but that's the general idea. Again, here's another example. We have a find one function. So let's say we want to find a specific user by their username via code, right? So let's say this function is called by someone else, like in a different class, for example, or it's used by an API. Our find user function can pass in a username and do some kind of where filtering via actual code. So this is specific JavaScript code. Don't worry too much about what's happening here. The idea is that we can do selects and inserts in code rather than in SQL. So to briefly go over our auction system that we looked at last time, if you didn't attend that workshop or just did recording, totally no worries. This is just to highlight a specific translation of how do we take code that we didn't use databases for into code that we use databases for. So here, I want to highlight a specific line, which is const auction equals auctions.getID. This is making a call to a hash map, which is not persistent data, which we talked about in the beginning of this workshop. If we want to convert this into a persistent database call, you can see there's a lot more code, but all that's happening here is the con.manager.find1 thing, where ID equals ID. You can see here we got rid of the persistent or the non-persistent map and converted it into a database call that's happening. So that's how we actually find the auction by using an ORM. So again, don't worry at all if you're not familiar with the syntax. The general idea of ORMs is what I'm trying to convey. Cool. That's all for the content for the workshop. I want to briefly mention a couple further topics for those who might be interested in exploring the world of databases some more. We barely covered the surface of SQL and relational databases. There's a course, like I mentioned, CSE 132A, which goes a little more into how databases work. So we look at different ways of querying. The class is kind of interesting. You'll learn a lot of SQL. You'll learn a lot more advanced SQL, like writing lots of group bys and lots of nested selects and all that kind of stuff. I think it's pretty interesting class. I really recommend it. For those of you who want to explore SQL some more, there's things like relationships that we didn't go over. So how to connect tables with each other, things like foreign keys that are related to relationships, join clauses with joining also related to relationships, with like joining together tables and then doing selects on those. Database indexing is something that is used to optimize performance when making queries. And this is very important if you have like millions and millions of rows of databases of data. And then advanced data structures that we can use inside our database to, again, do performance related things. A quick plug for ACM's development team. If you are interested in these topics, ACM has a development team that makes a portal, like our membership portal, and we actually use every single one of these concepts in our code. So I'm one of the backend developers on there. So we work with relationships, foreign keys, join clauses, database indexing, advanced data structures, a lot of the time in our code. So if this is something that's of interest to you, we are like recruiting people next quarter, so you can feel free to apply there. But yeah, I don't have a closing slide for some reason, but that's all for the workshop. Thanks for coming. I appreciate everyone who stayed this long. I'll stop the recording for now.